இருக்க போர்ஷன். மோஸ்ட் ஆஃப் த டைம் சாயிலில் இந்த மூணுமே இருக்க தான் போகுது. சம் ரேர் கேசஸில் ஆர் லேப் கண்டிஷன்ஸில் உங்களுக்கு வந்து இந்த சிச்சுவேஷன் மாறும். ஒரு டூ ஃபேஸ் சிஸ்டமாக மாறுறதுக்கு சான்சஸ் இருக்குது. எய்தர் சாலிட்ஸ் ப்ளஸ் வாட்டர், ஒரு டூ ஃபேஸ் சிஸ்டம். It happens for a fully saturated soil. There won't be any air present in the voids. Okay. In some other cases, for a fully dry soil, there won't be any water in there. Okay. It happens during oven drying. So 24 hours over drying பண்றப்போ உங்களுக்கு வாட்டர் நம்மளால ரிமூவ் பண்ண முடியும். There are different types of water present in the soil. Yeah, structural water, absorbed water, capillary water, different types of water is there. இதில் ஸ்ட்ரக்சரல் வாட்டர் மட்டும் பிரேக் பண்ண முடியாது 100 டிகிரிஸில். மற்ற எல்லா வாய்ட்ஸில் இருக்க வாட்டரை பிரேக் பண்ண முடியும். ஸோ ஸ்ட்ரக்சரல் வாட்டர் அப்படின்றது அந்த கிரெயின் ஃபார்மேஷன் கிரெயின் ஃபார்மேஷனில் அந்த பாண்டிங்கில் இருக்கிற வாட்டர் ஸ்ட்ரக்சரல் வாட்டர். ஓகே, ஆக்சுவலாக நம்ம வாட்டர் கண்டென்ட் கால்குலேட் பண்ணுறப்போ அந்த வாட்டரை பற்றி நம்ம பேசவே இல்லை. கொஞ்சம் கிளியராக இருங்க. நம்ம வந்து எல்லாமே சம்ஸில் இல்லை ஸ்லைடில் இருக்கிறது மட்டும் நமக்கு எக்ஸாமில் கேட்பணும்னு சொல்ல முடியுது. ஸோ நான் பேசுகிறதுல சில இம்பார்ட்டண்டான பாயிண்ட்ஸும் வரும். ஸோ அதை அப்பப்போ மைண்டில் வந்து ஸ்டோர் பண்ணிகிட்டே வரும். ஓகே, ஸோ நம்ம ஓவன் ட்ரையிங் பண்ணுறப்போ ஸ்ட்ரக்சரல் வாட்டர் ரிமூவ் ஆகாது. 100 டிகிரியில் பண்ணுறப்போ ஆகாது. நார்மலாக நம்ம ஒரு டெஸ்டிங் மாய்ஸ்சர் கண்டென்ட் டெஸ்ட்டுக்காக ஒரு 100 டிகிரிஸில் நீங்கள் ஓவன் ட்ரை பண்ணுறப்போ பார்த்தீங்க அப்படின்னா நம்மளுக்கு வந்து ஸ்ட்ரக்சரல் வாட்டர் ரிமூவ் ஆகுது. பட் வாய்ட் ஸ்பேசஸில் இருக்கிற மற்ற வாட்டர் எல்லாமே ரிமூவ் ஆகுது. ஓகே, ஸோ அந்த மாதிரி சுச்சுவேஷனில் உங்களுக்கு ஒரு டூ ஃபேஸ் சிஸ்டம் ப்ரொடியூஸ் ஆகும். சாலிட்ஸ் அண்டு ஏர் மட்டும்தான் இருக்கும். ஸோ வாய்ட் ஸ்பேசஸ் கம்ப்ளீட்டாக ஏர் வந்து ஃபில் பண்ணியிருக்கும். there won't be any moisture, வாட்டர் இருக்காது. பட் அப்பார்ட் ஃப்ரம் திஸ் சிச்சுவேஷன்ஸ் உங்களுக்கு த்ரீ ஃபேஸ் சிஸ்டம் ப்ரிடாமினண்ட்டாக இருக்க போகுது நீங்கள் நம்ம எந்த சாயில் எடுத்தாலும். ஓகே, ஸோ இப்போ இந்த டோட்டல் வால்யூமை நம்ம வால்யூம் ஆஃப் சாலிட்ஸ், வால்யூம் ஆஃப் வாட்டர், வால்யூம் ஆஃப் ஏர் அப்படின்னு சொல்லி பிரிக்கிறோம். இதில் இந்த வால்யூம் ஆஃப் வாட்டரும் வால்யூம் ஆஃப் ஏரும் இந்த சாலிட் கிரெயின்ஸ்க்கு நடுவில் இருக்கிற வாய்ட் ஸ்பேசஸை ஃபில்அப் பண்ணுது. கிளியர்? ஓகே, ஸோ ஒரு கிளஸ்டர் ஆஃப் கிரெயின்ஸ் உங்களுக்கு ஃபார்ம் ஆயிருக்கு அப்படின்றப்போ அந்த கிளஸ்டரில் அந்த கிரெயின்ஸ்க்கு நடுவில் இருக்க சின்ன சின்ன கேப்ஸில் அந்த வாய்ட் ஸ்பேசஸில் ஏர் அண்ட் வாட்டர் ஃபில் ஆகுது. ஓகே, ஸோ அதனால நம்ம ரெண்டுத்தையும் ஆஸ் அ ஹோல் வால்யூம் ஆஃப் வாய்ட்ஸ் அப்படின்னு சொல்லி டேர்ம் பண்ணுறோம். இந்த விவி டேர்ம், வால்யூம் ஆஃப் வாய்ட்ஸ் டேர்ம் வந்து கால்குலேஷன் டைம்ஸில் நம்மளுக்கு யூஸ்ஃபுல்லாக இருக்கும். ஓகேவா? ஸோ அதனால தான் இந்த டேர்மு இவ்வளோ ஸ்ட்ரெஸ் பண்ணி சொல்கிறது. ஸோ வால்யூம் ஆஃப் வாய்ட்ஸ் அப்படின்றது சாலிட் போர்ஷன் தவிர அந்த சாயில் மாஸில் இருக்கிற எல்லா ஏரியாவுமே எல்லா வால்யூமுமே வந்து வால்யூம் ஆஃப் வாய்ட்ஸ் தான். ஓகே, நம்ம ஃபஸ்ட்டு கன்ஃபியூஷன் எங்கே வரும் அப்படின்னா சாயில் மெக்கானிக்ஸ் போகிறப்போ இந்த சாலிட்ஸ், சாயில் இந்த ரெண்டு வேர்டுக்கும் நடுவில் கன்ஃபியூஷன் வந்து வரும். ஓகே, ஸோ சாலிட்ஸ் அப்படின்றது வெறும் கிரெயின், இந்த கிரெயின்ஸ் மட்டும் தான், இண்டிவிஜுவல் கிரெயின்ஸ், சின்ன சின்ன பார்ட்டிகல்ஸ், செடிமெண்ட்ஸ், வெதரிங் நடக்கிறது மூலமாக நமக்கு ஃபார்ம் ஆகிருக்கிற பார்ட்டிகல்ஸ். ஓகே, ஸோ தோஸ் கிரெயின்ஸ் ஆர் டேர்ம்ட் அஸ் சாலிட்ஸ். பட் as far as soil is concerned, it is a mass. So it consists of solids, water, and the grains, and the air, all three. In most of the situations, in some situations, there may be two substances, solids and water, or solids and air. Okay, right. So volume வச்சு செப்பரேட் பண்ணுறப்போ செக்ஷன்ஸை இப்படி தான் பிரிக்கணும். இந்த ஏரியாவில் ஏதாவது டவுட் இருக்குன்னா நீங்கள் ஸ்டாப் பண்ணால் பண்ணுங்கள். நெக்ஸ்ட்டு வெயிட் வச்சு பார்க்குறப்போ weight of solidsக்கு weight of soil total weight W அப்படின்னு சொல்லி எடுத்துக்கலாம். ஓகே, அந்த W it comprises of weight of solids WS, weight of water WW, weight of air WA. இங்க நமக்கு weight அப்படின்னு சொல்லி பேசுறப்போ வெரி பேசிக் மிஸ்டேக் என்ன ஆகும் அப்படின்னா, weight அப்படின்னா நம்ம வந்து kg அப்படின்னு சொல்லி எடுத்துப்போம் மைண்டில். ஸோ இட் இஸ் நாட் தட் கேஸ். மாஸ் தான் நம்மளுக்கு கேஜியில் வரும். வெயிட் அப்படின்றது இட் இஸ் ஃபோர்ஸ் யூனிட், ஃபோர்ஸ் டேர்ம். ஸோ நியூட்டன்ஸில் உங்களுக்கு ஆன்சர் வரும். ஸோ அதை மைண்டில் வச்சுக்கோங்க. ரைட், இப்போது இங்கே பார்க்குறப்போ வெயிட் ஆஃப் சாலிட்ஸை WSன்னு சொல்கிறோம். வெயிட் ஆஃப் வாட்டர் டேர்ம் இட் இஸ் WW, அண்ட் வெயிட் ஆஃப் ஏர் டேர்ம்ஸ் இஸ் WA. And as far as WA is concerned, for calculation purpose, we'll take it as 0. So WA நம்ம 0 அப்படின்னு சொல்லி எடுத்துக்கோம் calculation purpose-காக. So this WA term, this becomes 0, okay, for calculation purpose. But actual actual situations air weight is there. There's some weight for air. Okay, but it is very very negligible when compared with this other two substances in soil, solids and water. Okay, so comparing those two, the weight of air is very very feeble one, and hence for all calculation purposes we are going to take that as 0. Yeah. So similar to this weight criteria, mass of soil, total mass is taken as m. We're going to split the total mass into 3 parts: mass of solids as ms, mass of water as mw, and mass of air as me. Once again, we're going to take this mass of air as 0 for all calculation purposes. Okay. Since it is going to be very very small amount. Okay. So in the phase relationship ஏரியாவில் இந்த டயக்ராமில் ஏதாவது டவுட்ஸ் இருக்குன்னா ரைஸ் பண்ணுங்க, கேளுங்க, நான் வந்து கிளியர் பண்ணுறேன். அப்படிலாம் நெக்ஸ்ட் இதுக்கு நம்ம மூவ் பண்ணலாம். You have any doubts, please ask, or else okay. So in that case, எதுவும் டவுட் இல்லைன்ற ஒரு கான்ஃபிடென்ட்டோட நெக்ஸ்ட்டு ஸ்லைட்ஸ்க்கு மூவ் பண்ணுறேன். இந்த ஃபேஸ் ரிலேஷன்ஷிப்ஸில் இருக்க ஃபார்முலாஸ், என்னென்ன ரிலேஷன்ஷிப்ஸ்? The very first one will be water content, or in other words moisture content. It is denoted by the letter small w, because for capital W we are already using that for weight. So weight calculate பண்ணுறப்ப நம்ம capital W யூஸ் பண்ணுவோம். இங்கே நம்ம வாட்டர் கண்டென்ட் ஆர் மாய்ஸ்டர் கண்டென்ட்டை ஸ்மால் லெட்டர் W வச்சு டினோட் பண்ணுவோம். இந்த இடத்துல மிஸ்டேக்ஸ் வரும். ஓகே, ஸோ அதனால் கொஞ்சம் கேர்ஃபுல்லாக இருங்க. ஓகே, இந்த இடத்துல மிஸ்டேக்ஸ் வரக்கூடாது. ஸோ கொஞ்சம் கிளாரிட்டியோட இருங்க. ஓகே, ஸோ இட் இஸ் சிம்பிள். It is the ratio of weight of water and the weight of solids, not weight of soil, weight of solids. ரொம்ப கேர்ஃபுல்லாக இருக்கும். Yeah, weight of solids, not weight of soil. ஓகே, கிளியராக இருங்க. ஸோ டினாமினேட்டரை வாட்ச் பண்ணீங்க அப்படின்னா WS இருக்கும், நாட் W. That is weight of soil. Weight of soil capital W கிடையாது, சாலிட்ஸோட வெயிட்டை மட்டும்தான் எடுத்துக்கணும். ஓகே, ஸோ நியூமரேட்டரில் உங்களுக்கு WW இருக்கும், டினாமினேட்டரில் WS will be there. ஓகே, ஸோ this is the formula for water content or moisture content. இந்த இடத்துல you can alternatively give the moisture content in terms of mass units. Just like using a weight WW by WS, you can alternatively use mass terms. There is MW instead of WW and MS instead of WS. Okay. So you can use any one of this formula, either this one or this one. You can use any one of this. Okay. Both are going to be the same answers. And காம்படிட்டிவ் எக்ஸாம்ஸ் பொறுத்த வரைக்கும் இந்த லிமிட்ஸ் வந்து உங்களுக்கு வந்து கொஞ்சம் தெரிஞ்சு வச்சுக்கணும். நீங்கள் டேர்ம்ஸ்க்கு உங்களுக்கு எல்லா டைமே கேல்குலேஷன்ஸ் கேட்பாங்கன்னு சொல்ல முடியாது. உங்களுக்கு இன்டெப்த்தாக கேட்கணும் அப்படின்றப்போ உங்களுக்கு வந்து உங்களோட அண்டர்ஸ்டாண்டிங்கை டெஸ்ட் பண்ணுவாங்க. ஜஸ்ட் கேல்குலேஷன் எபிலிட்டி மட்டும் டெஸ்ட் பண்ணாமல் உங்களோட அண்டர்ஸ்டாண்டிங் எவ்வளோ இருக்குது அந்த டெர்மினாலஜியில் அப்படின்றத டெஸ்ட் பண்ணுவாங்க. ஸோ அப்படி டெஸ்ட் பண்ணுறப்போ நீங்கள் லிமிட்ஸ் தெரிஞ்சுக்கணும். லிமிட்ஸ், யூனிட்ஸ் இதெல்லாம் தெரிஞ்சு வச்சுக்கணும். யூனிட்ஸ் மேபி உங்களோட மெமரி டெஸ்ட் பண்ணுற மாதிரி இருக்கலாம், பட் உங்களோட அண்டர்ஸ்டாண்டிங் டெஸ்ட் பண்ணுறதுக்கு இந்த லிமிட்ஸ் வந்து யூஸ்ஃபுல்லாக இருக்கும். கொஞ்சம் திங்க் பண்ணி பாருங்கள். வாட்டர் கண்டென்ட்க்கு லிமிட் அப்படின்றப்ப நம்ம எந்த டேர்முக்குமே லிமிட் என்ன சொல்ல வரோம் அப்படின்னா லோவர் லிமிட் என்ன, ஹையர் லிமிட் என்ன, ஆர் அப்பர் லிமிட் என்ன. ஓகே, ஸோ அப்படி தான் வந்து டெஸ்ட் பண்ண போகிறோம். ஓகே, ஸோ லோவர் லிமிட் ஏதாவது இருக்குமா அப்படின்னு சொல்லி வாட்டர் கண்டென்ட் டெஸ்ட் பண்ணுறோம். ஸோ லோவர் லிமிட் அப்படின்றப்போ நம்மளுக்கு 0 ஆகிறதுக்கு சான்ஸ் இருக்கா அப்படின்றது வந்து பார்க்கணும். இங்கே நம்ம இன்ஜினியரிங் வந்துட்டு அப்புறம் சாயில் மெக்கானிக்ஸ் பொறுத்த வரைக்கும் நெகட்டிவ்ல பெருசாக உங்களுக்கு லிமிட்ஸ் வராது, பாசிட்டிவ் லிமிட்ஸ் தான் இருக்க போகுது. ஸோ பாசிட்டிவ் லிமிட்ஸ் அப்படின்றப்போ லோவர் மோஸ்ட் லிமிட் நீங்கள் 0 அப்படின்றத எடுத்துக்கலாம். கான்ஃபிடென்ட்டாக அதில் நீங்கள் இருக்கலாம். நெகட்டிவ்லலாம் போமா அப்படின்னு சொல்லி யோசிக்க தேவையில்ல. நெகட்டிவில் போக சான்சஸ் கிடையாது இந்த டேர்ம்னே. ஸோ உங்களுக்கு 0 தான் லோவர் மோஸ்ட் லிமிட்டாக இருக்கும். மேபி லோவர் மோஸ்ட் லிமிட் உங்களுக்கு 0வாக இருக்கலாம். ஓகேவா? ஸோ எந்த ஒரு டேர்முக்கு நீங்கள் லோவர் லிமிட் டெஸ்ட் பண்ணுறப்பையும் செக் பண்ணுறப்பையும் 0 வருதா அப்படின்றத பாருங்கள். ஓகே, ஸோ லோவர் லிமிட் பாயிண்ட்டை அங்கேருந்து ஸ்டார்ட் பண்ணணும். ரைட். ஸோ இப்போ வாட்டர் கண்டென்ட் நம்மளுக்கு 0 ஆகணும் அப்படின்னா நம்மளோட நியூமரேட்டர் டேர்ம் இந்த WW இந்த டேர்ம் வந்து உங்களுக்கு 0 ஆகும். ஓகே, ஸோ இந்த டேர்ம் உங்களுக்கு 0 ஆகும் அப்படின்றப்போ எஸ் ஷோர். I will proceed in English. Sure. So we have to check the limit for any property. So as far as water content is concerned, we are going to first check the lower limit. Okay, so for lower limit we can start from 0. Okay, so for this term to become 0, for water content to become 0, this numerator value it should be 0. Just think, if there is any case this numerator value, that is weight of water, will be 0. Just imagine, for oven dried soil, what will be the weight of water? For oven dried soil, as I already pointed out in the space diagram, as I already pointed out during this discussion of this slide, for a two-phase system, taking a fully saturated soil, fully dry soil, that is oven dried soil, there won't be any water. There will be just weight of solids and weight of air. Again, it is going to be 0. That's some other case. So there won't be any weight of water, okay, for a completely dry soil, or in other words, oven dry soil. For oven dry soil, this numerator term WW, it is going to be 0. So there is a chance for this water content to become 0. There is a chance, but why I haven't mentioned greater than or equal to 0 in this case is because in practical situations, as I already said, there will always be some moisture in water. For that case, I have not added that greater than or equal to symbol here. Yeah. So actually, if you see different textbooks, there will be different arguments about this water content, the limit, lower limit for water content. Some textbooks, they discuss like this. In practical situations, all type of soils have at least a small portion of water will be there. So water content will never be 0. That will be the discussion in some textbooks. But in some textbooks which speak in more theoretical manner, they will argue with this point. For oven dried soil, the water content will be 0 or maybe 0. Okay. So for safer side, you can say like this. You can cut this one. Theoretically, there is a chance, and also in lab also there is a chance. For this case, the water content can be 0, can be equal to 0. Okay, so this is about lower limit. It can be 0. It can be 0. So what about the higher limit? Is there a barrier for higher limit? We have to check it. Okay. Barrier in the sense, what we are speaking here is 100% limit or it can be more than that, like that. So as far as soil is concerned, when we are discussing about any property, we have to check this. For lower limit, it can it be 0 or not? For higher limit, can it be 100 or less than 100 or more than 100, like that? We have to check it as far as upper limit is concerned. So think about this situation. For the water content W to be 100, this WW this WW should be equal to WS. Yes, can you understand? For this water content small w to be 100 percentage, the weight of water present in the soil mass must be equal to the weight of solid grains present in it. For example, if you take a soil mass, the mass of the soil is 1 kg. Let's take it for example. In that, 500 grams, that is 0.5 kg of that mass is contributed by the solid grains present in it. And the rest of the mass, that is the remaining 0.5 kg or 500 grams, is contributed by the water present in it. In that case, both the numerator and denominator are going to be same. In that case, there is a chance the water content can be 100 percentage. It is possible. It's a very general case too. Okay. For high moist soils or during rainy seasons, it is a familiar scenario. The water content can easily go to 100 percentage. It is possible. Okay. Okay. So no, can we fix that at 100 percentage, the upper limit? No, we can't do that. We have to check, go a step further. Can the weight of water or mass of water be more than the weight of solid? Is that possible? Okay. We have to check that. So that case is also possible. In most of the sedimentary rocks, okay, this situation is possible. That is, I'm sorry, soils formed through those kind of rocks or very loose soils or even fine-grained soils, this situation is possible. Okay, or soils nearby, um, in vicinity of a water body, this situation is possible. The mass of water or weight of water will be more than the mass of solids or the weight of solids. Okay, so in that case, there is a possibility the water content, so the water content can be more than 100 percentage also. This case is also possible. So as far as water content is concerned, we can't fix an upper limit. Okay? We can't fix an upper limit for water content. So if there is a question, what is the limit for water content? Okay? Your answer will be this. If there is an option like this, I'm sorry, like this. If there is an option like this, say it is an MCQ multiple choice question, what are the 4 options? If there is an option like this, water content can be equal to or more than 0, then you have to pick this one. There is no option like this, and you have only an option like this. Water content is more than 0, like in this case. As I have sorry, as I have mentioned in my slides. You don't have an option like this, but you do have an option like this, then you can safely go for this one. Water content is more than 0. But what you have to do, if both these options are present, means you have to go for this one. Water content is more than, sorry, greater than or equal to 0. You have to pick this option. Yeah, sure. Right. Then move to the next property. The next 4 or 5 definitions or terminologies, we are going to take it under volumetric relationships category. Just a minute. Okay. Volumetric definitions, in that the first one will be void ratio denoted by the letter E. Okay. So it is the ratio of volume of voids to the volume of solids. So first of all, this void ratio and the next porosity parameters. This will be useful to identify the denseness or looseness of the soil. We are going to use these two parameters for finding, quantitatively finding the denseness or looseness of the soil. So this void ratio gives a measure of the total volume of voids present in the soil. So it will be given by VV divided by VS. Once again, as we did with the water content terminology, we have to set or check the limit for a void ratio too. First, we start with the lower limit. Is there a possibility of void ratio becoming a 0? Okay. So what I said, whenever you check the limits for a terminology or property, you do it with the mathematical expression of the property. Yeah. So here the mathematical expression is VV by VS. So for the void ratio E to become 0, this VV, it has to become 0. Right. Just check it. Is there a possibility for that? Is there a case where the volume of voids of a soil mass will become 0? Just think about it. Is that the possibility? Just think. For a soil, for a soil mass, there is no voids. There is no voids. It's full of solid grains. Do we call that a soil? We have to call it a solid, not a soil or rock, something like that. Even rocks do have a naturally formed pores in it. Okay, so during solidification process, rocks too contain some pores. Just speaking, um, there is no voids present in a soil mass. Then we should not call it as a soil mass. We have to call it as a solid. Okay, it is not a soil, right? Okay, so naturally, the soil is going to be a three-phase system predominantly, or in some cases, two-phase system. But it can't be a single-phase system. It can't be a solid. Okay, so this VV, this will never become 0. VV will never become 0. Then obviously the void ratio will never be 0. So the lower limit of void ratio is always, it is going to be 0. Right? Clear? So just moving on to the upper limit, check it. If there is a possibility, the VV can be, just check, it can be more than VS. Think about it. Is there a situation for this talker, the volume of voids is more than volume of solids? It is very much practical. The volume of voids can be more than volume of solids. In most of the fine-grained soils, voids will be more than volume of solids. If you remember your fourth semester problems, that is during your academic classes, okay. If you remember those problems, if the soil discussed in that problem is a fine-grained soil, maybe a clay or silt, the void ratio, most of the time during academic problems, they will give the void ratio values or specific gravity values in the given data itself. So if you have that much memory, just think of it. If a clay soil or silt soil is discussed or is the matter of discussion in that problem, the void ratio will be more than 1. You should have seen that. If you remember, you can see that. Or else, after this session, you can go and take your textbooks and take any problem which has either a given data as a void ratio or the recorded data as a void ratio. Just look into the problem. If it is a fine-grained soil, the void ratio value will be, most of the time, it will be more than 1. Okay. For a coarse-grained soil, the void ratio may be less than 1. Okay. So this situation here, the volume of voids is more than volume of solids situation. It is very much practical. So in that case, the void ratio, the value of void ratio, it can be more than 1. Remember, the void ratio is not expressed in percentage. In the previous case, as far as water content is concerned or moisture content is concerned, it is expressed in percentage. So if you look into that mathematical expression, you can see it is multiplied by the 100. But here we won't do any sort of those things. It's simply a ratio. So the lower limit, upper limit values, it should be we have to discuss with the numbers 0, ones, and so on, not with the percentages. Okay. So here the upper limit value, it can be more than 1. There is a possibility. Okay. So for void ratio also, we can't fix an upper limit. Okay. So look into this last point. Practically speaking, this mistake we all may do. We sometimes we go too much, we apply too much of our practical thinking, and we may answer incorrectly. This happens for void ratio. If you see uh, gravel mass and a sand mass, okay. If you see a mass of gravel in a container and a mass of sand in another container, if we ask the void ratio of which one of those two containers will be high, we blindly say the void ratio in gravel will be more. We do this mistake all the time. Okay. If we don't dig deep into that, this void ratio terminology, there's a maximum chance we will do this mistake. Okay. So practically, the voids in coarse-grained soil may be bigger in size, but the number of voids is very, very less. Can you get my point? For a coarse-grained soil, let's say for an example, we have a 1 liter container. We pour gravel in it, starting from a 4.75 mm size or even 20 mm gravel. Say for example, take a 20 mm gravel mass. Okay, we pour a 20 mm gravel mass, a 20 mm size gravel mass in that container, and in other container we pour a clay soil or a silty soil. Okay, or just for example's sake, take a sand mass. Okay, take a mass of sand in another or 1 liter container. If you see that 1 liter container which contains gravel may have a piece of maybe or 50 or 100 pieces of gravel in it, or some 50 pieces of gravel in it. But in case of a container which is filled with sand, there may be pieces of uh, 10,000 or 20,000 or more than that, thousands of pieces of particles, individual particles of sand in that container. So if we see, look into the voids in those two containers, the number of voids in the gravel container will be very much less. It will be around some hundreds or 200s. Okay, even though the size of the voids is much bigger, but the number of voids is very less. Can you take my point? You get my point? The size of voids is more or big in coarse grained soil, but the number of voids is very less for the same volume of soil. Okay, clear? But when we come to this sand container, the size of voids is very less, in some millimeters or even some microns, the void sizes. But the number of voids, we count that, will be much more, some thousands or even lakh or million, like that. Okay, so in that case, if we uh, add all those smaller voids, it may be more than the voids volume of that gravel portion. So in that case, the void ratio of fine grained soils are generally higher. So this is the point I'm trying to prove here. So don't do this blunt mistake. If you have done that previously, don't do it again. If you get posted with a question like this, the void ratios of a coarse grained soil is bigger or smaller than a fine grained soil. If you get a question like this, I have to answer in this way. Okay. The void ratio of coarse grained soil will be generally less than that of fine grained soil. Maybe the void sizes may be bigger, but the number of voids are less, and hence eventually the void ratio value is going to be less as compared with that of fine grained soils. Okay. Keep that in mind. Okay. So this final point, this is very important. Take this into account. Clear? Next one. Porosity, another term for expressing the denseness or looseness of a soil. Okay. So it is defined as the ratio of volume of voids to the total volume. So here, what is the difference between the void ratio and porosity? Generally, students or even aspirants make this mistake. They will get confused with void ratio and porosity. So void ratio, there is no change in the numerator, but the denominator, it is volume of solids as far as void ratio is concerned. But here, porosity, the denominator, we are taking the total volume of the sample or soil mass. We are not taking only the volume of the soil solids. Okay. So this is a big change. I have to take this. Okay. Another one will be porosity. It is generally expressed in percentage. Actually, I have to put a. We have to multiply this with 100 percentage. The actual formulas like this. Okay. Right. So again, let's check the lower limit and the upper limit for porosity. Okay. Is there a chance of porosity becoming zero? As I already said during void ratio, it is not possible because the volume of voids will never be zero as far as soil is concerned. So hence, the porosity value, the lower limit, it will never be zero. And let's move on to the upper limit. If there is a chance the volume of voids is more than the total volume of soil, it is not possible, right? Okay. And let's check another term also. Is there is a possibility that the volume of voids of the soil mass is equal to the total volume? Is there a possibility? Okay, just to keep the porosity value as equal to 100. For that, we have to check this condition. Okay, just check it. Is that possible? Okay, if the situation occur, we are dealing with some space, not some soil. Okay, just think it. If the total volume is occupied only with voids, what we are discussing with them, there, there's not any soil or any sort of things, right? So we are speaking about soil here. So This will never happen because there is always going to be some solid. There is always going to be some solid Vs. Like we are saying, as we are saying, there is always going to be some voids in soil mass. It is so true. There is also going to be some solids in every case. So this condition is not possible. And hence n, the value of n turning out to be 100% is also not possible. So we are setting this limit. Have any doubt? As so the value of n, it is going to be between 0 and 100, not from 0 to 100. You have to clear in that. Um, Believing you people are from final year and pre-final year, you may attend some aptitude classes and you may be familiar with these terms between and from. You may be familiar with the difference between these terms. So the porosity value, it will be between 0 and 100, and it is not from 0 to 100. You have to be clear in that. Okay, it won't be 0, it won't be 100. It is going to be some value between those two numbers. Okay, be sure about that. Right. So as far as civil engineering is concerned, we are going to prefer the void ratio and not the porosity in most of the cases. But in academic point of view, we use porosity for calculation purposes. But practical situations, we prefer the void ratio terminology more as compared to the porosity. But why are we discussing about this porosity means there is some difficulty in finding the volume of solids alone. So for that case, calculating the total volume is much easier than finding the volume of solids. So for that case, we will go with the we will find the porosity in the first step and we will move to the void ratio in practical situations. So for that case, we are dealing with this porosity here. Okay, so but um, in if we talk about giving priority to discuss about density of soil, we have to give priority to which term means first priority will be for void ratio in this two. For speaking about void ratio and porosity, we have to give more priority or first priority to void ratio if we are going to discuss about the denseness or looseness of the soil. There is one more term which discusses the density of the soil. It is called as relative density. But the difference is relative density, we deal with coarse grained soils only. We won't apply that relative density term for fine grained soils. So that's why I'm not bringing that up here. Or else I will say relative density should be given the first priority. If you have to discuss, if you are going to discuss about the prior densities of the soil. Okay? But for to keep things in a generic manner, we are only comparing these two things, void ratios and porosity. So in these two, civil engineers, they have to give priority for void ratio, and the agricultural engineers, they will deal with the porosity. Right. So there is a reason for that. You can see that in this final line. In void ratio, only this thing changes, this numerator. Volume of voids changes in void ratio. But in porosity, when volume of voids changes, automatically this total volume changes. So if you have to find how the porosity changed, it may be whether it is because of the change in volume of voids or total volume, we may get stuck into that. Okay? We may end up in some confusions. So for the purpose, we prefer void ratio more as compared with the porosity. Right? So the next property will be a degree of saturation. Okay. So the previous two terms we deal with the voids, but the next two terms will be further we are splitting the voids part, that is as a water and as air. So in that first one will be about water, that is degree of saturation. Okay. So degree of saturation denoted by the letter capital S or SR. So it is the ratio of volume of water to the volume of solids. So again, it is expressed in percentage. This you may not end up in confusion because the word degree is preceding the terminology. So if it is there, we will know the answer is going to be in percentage. So right, uh, speaking about the limits, here are the cases discussed. For a dry soil, the volume of water it will become zero, and hence there is chance this degree of saturation to be zero. That's why we are using equal to here. Okay. So for a fully saturated or completely saturated soil, the entire void area is going to be occupied by the by water alone. There won't be any air. So we have to first understand what the difference between the dry soil, partially saturated, and fully saturated soil. A dry soil means the entire void spaces between those solid grains. Okay, it is occupied only with the air. There won't be any water. Again, I'm telling the situation happens in lab. During oven drying, the situation happens. The entire water is evaporated during heating. There will be only air gaps between those solid grains, a solid skeleton. Okay, so that case we can call it as a dry soil. And for fully saturated soil, the entire white spaces is filled with water. This situation happens when the soil is flooded completely with the water. This situation happens. So in that case, the entire air voids is expelled from the soil mass, and hence the VV it will become VW. Okay, so the entire volume of voids will be occupied by volume of water, and hence the VW is equal to VW. You can write like that, and hence the value of S will be equal to 1, or in percentage we can say it as 100%. Okay, so both these cases are possible. Now think about, if there is a situation where VW more than VV, is this possible? No, it is not possible case, because as far as soil is concerned, the void spaces, I'm sorry, the water can be occupied in the void spaces only. It cannot occupy any other spots. Leave the structural water which I discussed earlier. Leave that. Just as mass I'm speaking, uh, the water can only occupy the void spaces. Okay, it can't go more than that. So this situation is not going to happen. And yes, there is degree of saturation value. It should be limited at 100% only. It can't go more than that. Okay. So when the soil is fully saturated, the limit is going to be 100% only, not going to be more than that. Okay. For a partially saturated soil means the void spaces is partially occupied with the water and partially occupied with the air. The value of S lies between 0 and 100. So the limit of degree of saturation is this: 0 less than or equal to S less than or equal to 100. These limits are very, very important since we are handling, uh, I'm sorry, since we are attending this class to face some competitive exams, it may be GATE or some other competitive exams. So these limits are very, very important. We can't just skip through these areas. And also, since this is first class and we are discussing these basic properties, I'm taking much time in discussing these limits, or else you can understand for next classes you can understand easily. Okay. The next property will be air content. That is, we are now moving on to the second part of that whites area. Okay. So first we discussed about the water degree of saturation. Now we are going to take the air volume of the whites volume into account. So air content, it is the ratio of volume of air to the volume of solids. Sorry, volume of whites. So it is similar to degree of saturation. Only thing is, instead of talking about water, we are going to take the air into account. So Az, it is equal to Va by Vv. Okay. In indirectly, we can measure like this. Air content is can calculate as 1 minus S. Okay. Can calculate like this also. Okay. If you if you have any doubt how this expression came, in the next few slides we will deal with this, so you can check that. Okay. So next, percentage air voids Na. It is another term like porosity. This is another term where we use total volume for reference. So percentage air voids Na is the ratio of volume of air to the total volume of soil. Okay. So Va by V. See the difference? Just like void ratio and porosity, here air content and percentage air voids are different in the denominators. So here Vv and here V. Can you see the difference? Right. So there is a relationship for air content, porosity, and the percentage air voids, and this is, and that one will be this. Na is equal to N into AC. Want to check how it came? Let's put it in the account. So N, what is N? Porosity. What is it? Volume of voids by total volume. Right. And the air content, here it is. So just check Na. Na is equal to N into AC. So N is Vv by V. AC will be Va by Vv. So Vv and Vv get cancelled. We get Va by V, which is nothing but the percentage air voids. This is how this relationship is. All right. All right. Okay. The next set of relationships will be about the weight or mass relationships. The first set is about the volumetric relationships, and the next set of relationships will be about the weight or mass relationships or definitions. Okay. Um, First one will be bulk unit weight or bulk density. Okay. So it is a ratio between total weight of the soil and the total volume of soil. So again, we have to, once again, I will show you this phase relationship slide so that you can once again refresh with this weight and mass terms. So here W, capital W means total weight, WS means weight of solids, WW means weight of water, and WA means weight of air, which is going to be 0. We'll take, next, similarly, mass, capital M denotes total mass, MS denotes mass of solids, and the MW denotes mass of water, and the MA denotes mass of air. Again, it's going to be 0. Just make you remember this terminologies. Next, let's get into those relationships. Weight volume relationship or mass volume relationships or definitions. Like the first one will be bulk unit weight. It is defined as the total weight divided by total volume, or bulk density we can call total mass divided by total volume. So first let's speak about this weight area. Okay, so total weight of soil, two parameters in the soil contribute for the total weight. The one will be weight of solids, that is solid grains. Another will be one will be the weight of water. Weight of air, as I already said, we'll take it as a 0. So we won't add that in here. WA, we are not adding here in calculation since we are assuming it as 0. Okay. So again, I'm reminding you, this is for soil mechanics only. But actually, there is some weight for air. We are not going to take this here because it is a very very uh, negligible value as compared with this two weights, weight of solids and weight of water. Right. Similarly, the volume here we can't remove the air part. Okay, we have to add that here. Okay, there is some, the air is going to occupy some volume here, some considerable volume here. Sometimes it may be more than volume of solids also. We don't know about that. Okay, so we can't simply remove as we removed the weight component of the air here. Okay, so here the volume, the total volume, it comprises of volume of solids, volume of water, and volume of air. Okay, so similarly you can write this mass terms also. So what about mass? Mass of solids ms, mass of water mw, there won't be any mass of air, and weight, sorry, I'm sorry, volume, volume of solids, volume of water, and volume of air. You can write for mass like this. Okay, here for soil mechanics, usually we express this bulk unit weight in kilonewton per meter cube, since it is going to be in large numbers or large quantity. When you go to construction site, the soil we are going to use will be very very high. Okay, so we are expressing that in kilos. Okay, but if you look in fluid mechanics or hydraulics papers, we usually solve the sums. There also this term is there, unit weight term. We also discuss this term in fluid mechanics, strength of metals, all those papers. But there we usually use Newton per meter cube like that. But here soil mechanics we use frequently use kilonewton, since the mass we are going to deal is going to be huge. So hence, to reduce the digits, we are putting a kilo in front. Okay, so kilonewton per meter cube, and the bulk density is expressed in gram per cc or ton per meter cube or kg per meter cube, whatever. Okay, you can express the bulk density in any of these units, gram per cc or ton per meter cube or kg per meter cube, anything. Okay, and the last point we already knew this one. Unit weight is equal to the product of density and the acceleration due to gravity. We have already studied about this in fluid mechanics itself. Again, just to make things clear. So how this arrived means, the force is equal to mass into acceleration due to gravity. F is equal to m into a, right? So here, unit weight, we are dealing with this weight. It is a force unit. Weight we are expressing in Newton, so it is a force, right? So density, it's a mass term. The term is, it deals with mass. Okay, so just like F is equal to m into a, we are writing this unit weight like this: density multiplied by acceleration due to gravity. We know the value of acceleration due to gravity. What is that? As far as the Earth is concerned, acceleration due to gravity, how much? 9.81 meter per second square. Okay, next. The dry unit weight, here we are not going to take the total weight, capital W. Instead of that, we are going to take the solids weight alone here, weight of solids alone here. Okay, so instead of writing W by V as we have written in bulk unit weight case, we are going to write as Ws by V here. Okay, weight of solids divided by total volume. Similarly for dry density, mass of solids divided by total volume. Yeah. So here mostly this is going to be a mathematical parameter. So it is also useful in measuring the denseness of soil. You can find the application of this parameter mostly when in problems dealing with the compaction of soil related problems. We can see the application of this parameter gamma d predominantly. We can see the application of this parameter in those problems. Okay. Uh, just qualitatively speaking, the higher value of dry unit weight indicates more solids are packed in a unit volume of soil and hence a more compact soil. This is a qualitative one. Okay. You can put some calculations and can say quantitatively the answer for it. But just for an indication, if the gamma d is value is more for a soil, the soil is well packed, or in other words, it is more compact. Just keep that in mind. But this kind of statements will be useful for you while you are facing AR type questions. You know that, right? Assertion, reasoning type questions. Nowadays, competitive exams are not only comprises MCQs, contains the MCQs, match the following types, true or false, it's old one, NAT type questions, numerical answer type questions, and assertion reasoning type questions. Mostly as assertion reasoning type questions will test your justification. If even we can say the assertion reasoning question, it's the next step for a true or false justify type of questions. It's the next stage in those questions, right? So this kind of statements will be useful for you when you're going to answer those type of questions, assertion and reasoning type of questions. Okay. Next, saturated unit rate. It is a actually we can't say this as a separate unit rate. This is a condition of bulk unit rate. We can safely say like that. This is a condition of a bulk unit rate. About speaking of condition, when the soil is fully saturated, then if you measure the bulk unit weight of the soil, then it is called a saturated unit weight. Nothing more than that. Okay. So if you measure the bulk unit weight of the soil in its fully saturated state, then it is saturated unit. It is not some special term or like that. Yeah. No need to get confused in this. Okay. So saturated unit weight, even we can write like this: gamma sat is equal to weight by volume. It is again a unit, bulk unit weight only, but the only change is under a condition. That condition will be saturated condition. So under saturated condition, if you measure the bulk unit weight, then it is saturated unit. You can write like this also. Uh, it will give a much clear picture for you. Okay. Right. Next, submerged unit weight or buoyant unit weight, or we can also call it as effective unit weight also. Okay. Can also term this as effective you can also term it as effective unit weight. So actually most of the terminologies or definitions which contains effective, the word effective in soil mechanics, those definitions were given by the father of soil mechanics, Terzaghi. So he uses this term effective into his theories. Mostly he uses this term effective into his theories. Um, right. Now moving to this. When a soil mass is submerged below the groundwater table, there will be a buoyant force, not only soil mass. If any object, if it is submerged in water, not flushed with the top surface of the water. I'm not speaking about that. If it is submerged inside water, there will be a buoyant force. Okay. So speaking of buoyancy, we know the definition of buoyancy. It is equal in magnitude to the weight of the water displaced by the object, we have to say in general term. But here, since we are speaking or dealing with soil, we have to say solids. Okay. The buoyant force acts on the soil solids, which is equal in magnitude to the weight of water displaced by the solids. Okay. So, because of this buoyant force, the net weight of the solids is reduced. This phenomenon we have already studied in school days itself. When an object is immersed or submerged in water, the weight of the object gets reduced. We know this. Okay. Here, the same thing occurs. The net weight of the solids is reduced once they get submerged in water. Okay. So, this reduces the unit weight. Once the weight of solids is reduced, obviously the unit weight is going to get reduced. Okay. This reduced unit weight is known as the submerged unit weight or buoyant unit weight, or in some theories or when we deal with some problems, we call the same parameter as effective unit weight, gamma dash or gamma prime. Say, okay. So this gamma dash or gamma sub, it is calculated from the saturated unit weight. So gamma sat minus gamma W. Okay. So for soils, the submerged weight is roughly one half of the saturated unit weight. Again, I'm telling this is for soils only, because most of the soils, the submerged, the saturated weight will be in the range of 20, 21, 22 in those region. I'm talking about the submerged saturated wind weight. It will start from some 18.5 or 18 from that range to 21, 22, much heavier soils I'm speaking. Okay, so the gamma sat value generally for soils, it will be in the range of 18 to at the max 22 or 23 kilonewtons per meter cube. Please keep this in mind. Okay, so now look into the statement. The submerged unit weight is roughly one half of the saturated unit weight. Why we are saying like this? Okay, look into this statement expression. The submerged unit weight gamma sub is equal to gamma sat minus gamma W. The saturated unit weight, we know the range 18 to 22. What is the value of unit weight of water? Do you remember this? I hope you will be familiar with the unit weight of water. What is it? The unit weight of water is 9.81 kilonewton per meter cube. This you have studied in fluid mechanics itself. That's all right. It's maybe you could have studied 2 years back. There's a fair chance you could have forgotten that. Right. Anyways, just now put this into this expression. Say, for example, the saturated unit weight of the soil is 19. Put this in the space, gamma set space. So 19 minus 9.81, it will again roughly it will come at 9.2, something like that. Okay, so that's why we are putting this statement here. The submerged unit weight is roughly one half of the saturated unit weight. Okay, I hope now you can understand why we have written this statement here. Okay. Please keep that in mind. It may be useful for you and some interviews, or if somebody asks this in some competitive exams, then we can say that question is very easy. But for interview purposes, the statement may be useful for you. Okay, just keep that in mind. Okay, now we have seen the different unit weights. Let's list that one by one. Gamma B, bulk unit weight. Gamma D, dry unit weight. Gamma saturated, gamma sat, saturated unit weight, and finally gamma submerged. So for a soil mass, for a same soil mass, we can calculate all these four unit weights. It is not like we can calculate if the soil, if we calculate the bulk unit weight for a soil, we can't do the remaining three. Or if we calculate the saturated unit weight, we can't calculate the dry unit weight of the soil. It is not like that. It is possible for a saturated soil also. It is possible to find the find its dry unit weight. It is possible. Okay, please don't keep that in mind. Keep understand. Keep your understandings like that. We can't find the dry unit weight for a saturated soil. It is not like that. Okay, the condition of soil is not going to do anything in finding this any of these four parameters. Okay, even if the soil is saturated, we can find the dry unit weight of the soil. Okay, right? It's not going to affect it. Right now, coming to the point of this four unit weights, we can put this in some order. You can place this in some order, means either a higher order or lower order, something like that. Of these four parameters, the gamma sub value will be much less. The least will be gamma sub. For the same soil, the submerged unit weight will be very less. It will be in the range of 9 or 10, something like that. 9, 10, 11, in that range only. The submerged unit weight for a soil. And the next one in the list, next higher unit weight for a soil in the list will be the dry unit weight. And the next one in the list will be what? The bulk unit weight, gamma B. And the next one in the list, that is for a given soil, the maximum unit weight of the soil will be its saturated unit weights. Or in other words, a soil attain its maximum unit weight at its fully saturated state. You can mathematically or even practically think how this happens. For a saturated soil, the entire white spaces is going to be occupied by the water. The weight of water is much higher compared to the weight of air, right? It's going to occupy some area in the remaining unit weights. Okay, so the entire white spaces is going to be occupied by the weight of by water. So hence, the saturated weight in the saturated state, the weight of soil is going to be very high. Okay, thereby the unit weight is going to be high. Okay, so just remember this order. It's very important one for competitive exams. This order. From least to the maximum, minimum to maximum. For the same soil, just make a note of it or keep that in mind. The submerged weight will be very less, and the saturated weight will be much higher. In between the dry and bulk, and between those two, the bulk is going to be a heavier one, and the dry going to be a lighter one. Because in dry, bulk soil, there will be some moisture, or in other words, we are taking the moisture into account. In dry unit weight, we are not going to take the moisture into account. So hence this difference. The bulk unit weight is much will be higher. I can't say much like we are saying with the submerged case, but it will be higher. The bulk unit weight of the soil will be higher than the dry unit weight of the soil. Okay. But of these four, the saturated is going to be much higher. Please keep that in mind. Next will be the unit weight or density of the solids. Just don't think we skipped this one in the list, because those last four unit weight parameters were dealt with the soil, not solids. Unit weight of soil. If you want just a small rewind or recap, bulk unit weight, just look at the denominators. We took the total volume into account, means we took the soil here. You can see in every definition, you can see the word soil, not solid, anywhere. Okay. So here also, volume of soil, total volume of soil. See, soil sample. Same. Okay. Right. But here, we are not going to deal with the total volume. Here, we are going to deal with this volume of solids only. So you can't keep this one and the last four in the same league. So this is a different criteria. So unit weight or density of solids, it is a ratio of weight of solids to the volume of solids. This is the place where the difference comes. So far, we were dealing with the volume of soil, but now we are dealing with the volume of solids. Okay. So as I mentioned the beginning of this session, you have to be very, very careful with these two words, soil and solids. So it will make a huge difference. Okay, so be careful with those two words. Right. Proceeding, density of solids. Again, it is the ratio of the mass of solids to the volume of solids. It's like a unit weight. We are speaking of density also. So it is denoted by the letter gamma S. Gamma S is equal to Ws divided by Vs, and rho S is equal to Ms divided by Vs. Okay. So again, this last line, very important one. Please keep this in mind. This kind of notes, small important notes, will be helpful for you in assertion reasoning type of questions. It will be very, very helpful for you because we are done with those true or false type of questions. Most of the competitive exams now we won't get those type of questions, true or false. Instead of that, we are getting AR type questions, assertion reasoning type questions. So this kind of statements will be very useful in this in answering those things. Right. Coming to the point, unit weight of solids, that is gamma S. It will be it is always more than dry unit weight. Just keep this in mind. Gamma S is always more than gamma D, dry unit weight of soil. Okay, where is the difference? If you see the volume parameters, that is denominator parameters, for calculating gamma D, we take total volume, which is a much higher one when comparing to the volume of solids, right? That we are using here in calculating the unit weight of solids, right? So since the unit weight is inversely proportional to the volume terms, um, gamma S is more than gamma D, because in gamma S we are using a lesser volume. There is only volume of solids is taken into account, but in calculating dry unit weight of soil, we are taking the total volume into account. That makes the difference here. Okay, right. Next, very important one, very familiar one, specific gravity of solids. There is specific gravity for every substance. So here, specific gravity of solids, G, sometimes call it as a GS. It is a ratio of unit weight of solids and the unit weight of water. The standard temperature for measuring this specific gravity is 4 degrees Celsius. It is also an important one. Maybe some state competitive exams, it will be useful. TNPSC, like that. Okay. The standard temperature for measuring specific gravity is 4 degree Celsius. Usually we won't do that. In lab classes, you might have done this experiment using some pygnometer or something like that. We done those experiments at room temperature only, 30, something like that. But the standard is we have to measure the temperature at 4 degrees Celsius. Just keep that in mind. Um, Here, the unit weight of water, again, as I already mentioned some slides before, can be taken as 9.81 kilonewton per meter cube. Okay, right. Again, if you want to find the specific gravity of solids using the density terms, okay, if you are using the unit weight terms, then unit weight of water you have to use as 9.81. In case if we are using the density terms to find the specific gravity, that is rho s by rho w, then you have to put the density of water. So when during fluid mechanics classes, we may use the density of water in kg per meter cube units. That is 1000 kg per meter cube. We will be familiar with that. But here, in soil mechanics, as I already said, when density terms comes, mostly we go with gram per cc or ton per meter cube units. So here, for a unit weight, so I'm sorry, density of water, you have to put 1 gram per cc. You have to use that value for in the denominator, right? This area. If you are going to use this formula for finding specific gravity, then for rho w, that is density of water, you have to use this. That's what I'm speaking. Okay. If you are going to use this formula, then for gamma w, you have to use this 9.81. This is very basic things, but some heat of moment or some pressure, exam pressure, you may do mistakes at this small things. Okay, so please keep this in mind. Okay. Next, some relationships. I'm not going to derive everything, but um, just to get familiar with this problem things, that is solving problems area. I'm showing these relationships, how they are derived. Okay, so the first relationship will be the total weight and the weight of solid and the what is that small degree water content. Okay, so the first relationship between will be between these three terms. Just look at this. My advice is, please don't memorize these final terms. Just try to derive the relationships. It is always safe for you. If you memorize these relationships, there may be chance that you may put some wrong terminology or wrong variable during your calculations. So my humble request is, just try to derive these things. Okay, you may feel a bit cumbersome, but they are actually easy. They are not much difficult things. Very easy there. If you go step by step deriving these units, you can easily find the relationships. Okay, no need to worry about that. So first, weight of solid. See weight of solid, total weight, and water content. See how the terminology is derived. So first, the total weight is segregated in split into two terms: weight of solids plus weight of water. We know this already. There is no weight of air, so the total weight is contributed only by these two terms: weight of solids and weight of water. Okay, so now we are taking the weight of solids outside. So the term equation becomes 1 plus weight of water by weight of solids. We know this. Weight of water by weight of solids. There is just nothing but here. It is given. It is water content. Okay. So this term becomes weight of solids multiplied by 1 plus W, like this. Okay. Now, rewriting the expression weight of solids is equal to taking this here. So total weight divided by 1 plus W. You may ask why we have to keep like this. Just why can't we finish from here itself? We arrived at some relationship why we have to go again for this step means now we are going to take things into some practical situations. Practically, the for finding practically finding the total weight is much easier than finding the weight of solids alone. This is also possible. I won't say this is not possible. Weight of solids. It is possible to find weight of solids. Okay, there won't be any difficulty in that. But it is much easier to find the total weight because you have to wait at least 24 hours to find this. I have to put the soil mass in the oven and heat it for 24 hours. Then only we can get this one. Okay, that's why if you need weight of solids, just get this and get this, then you can find WS. Okay, right. Okay. Next, the relationship between bulk unit weight gamma B and dry unit weight gamma D. Similar here, we spoke with the simply weights, and here we are taking the things into unit weights. That's it, nothing else, nothing more. Okay, we know WS is involved with the gamma D and the W is involved with the gamma B. Just replace with these things. If further need the derivations, you can see here how the things are arrived. Just what we did here, we are repeating the same things here. Okay, clear? Right. Next, a very important one: the relationship between E and N, void ratio and porosity. You can go in. You can start in any way, either keeping porosity and at LHS and deriving the equation in terms of E, or you can put E as a dependent, okay, at LHS and find the equation, write the equation in terms of porosity. You can do it in any way. Right. First, we are moving in porosity. So porosity is given by VV by V. So again, the total volume can be separated as Vs plus Vv. So as we did with this WSW and a small w derivation, we are doing the same strategy here. So taking V volume of solids outside, we'll get 1 plus Vv by Vs. So now we know Vv by Vs is Vv by Vs is E, and here another Vv by Vs. So this is again E. Okay, so you can write porosity N is equal to E divided by 1 plus E. That's how these equations arrive. Similarly, you can do the things in reverse. So E is equal to VV by Vs. So now Vs we can write as total volume minus volume of voids. We know that. Okay. So volume when we subtract the volume of voids from the total volume, we get volume of solids. That's what we are doing here. Okay. So now we're taking the total volume out. Then we get 1 minus VV by V. Here again the same thing. VV by V is equal to N, and this VV by VV will become N. So the answer will be N by 1 minus N. Okay. So we already discussed about the limits of different properties we discussed so far. So again, this is just a reminder. From these two expressions also, we can come to a conclusion that the value of N, it cannot be more than 1. That is N is porosity is generally expressed in percentage, so that's the way I have put that here, percentage, 100%. But E can be more than 1. Just look at these expressions also. Okay, so once I take this, say the value of E may be even, it may be 100, but the denominator will become 101. So the N will never be equal to 1 or even more than 1. Okay, this statement again proves that this expression again proves the proves our limits statement. The value of n cannot be more than 1 or even equal to 1. Okay, that we have discussed here. See, again it is proved. Similarly, if we take this expression into account, the void ratio value may be, it can be more than 1. It is possible. If, say, the value of porosity is 100 percentage, actually it won't arrive, say 80 percentage. So 80 divided by 1 minus 80 is going to be 79. So obviously the answer is going to be more than the value. Okay, more than 1. So this chance, there is a possibility for this. Okay, so right, next, say, for example, if the porosity, say we will take a few examples. We'll take in two ranges. For example, 40 percentage porosity, we'll take that as case, and 60% porosity, we'll take that as another case. Just put into this equation, see what happens. So for first case, the value of E, how much it will come? So 40 percentage, during calculation, we have to put it in decimals. So 0.4 divided by 1 minus 0.4, it is 0.6. Okay, so 0.4 divided by 0.6. Okay, so the value is going to be 0.66 for this case. 66 or 67, something like that. Okay, if we go with the next case, 60 percentage case, value of E will be 0.6 divided by 1 minus 0.6, it is 0.4. So in this case, the value will be 0.6 divided by 0.4. It will be equal to 1.5. So with these two examples, the statement is again proved that the value of void ratio, it can be more than 1. Clear? But the porosity cannot be more than 1. We have already discussed. I hope you will understand these things. Next, again, a relationship between void ratio E, water content W, small w denotes water content, and G, specific gravity, and S, what is that? Degree of saturation. Look at this derivation. We'll find, get this final expression. E is equal to Wg divided by, yes, there are many forms of this expression actually. Okay, so you can write like Se is equal to Wg. I usually ask my students to remember this expression in this way. You can easily remember this sewage. SEWG, sewage. You can remember like that. You won't forget this expression. Okay, so already say I said don't memorize the expressions, but at some, if you forgot to derive this thing, then you can remember like this. Keep this in your memory like this. Sewage, Se is equal to Wg. Remember this relationship between these four in this manner. Definitely, you won't make a mistake. Yeah. Okay. Then you can from this we can write the different variations of this expression. Sewage. Just keep this in mind. Okay. From this, you can arrive this expression or in some other format also. Okay. So actually, this expression reduces for a fully saturated soil like this. For fully saturated soil, the S value will become 1 and this expression will get reduced like this for a fully saturated soil. Saturated soil. For saturated soil, you can write this expression or reduce this expression into this one. E is equal to W into G. Okay. The next one, the relationship between the bulk unit weight of water, specific gravity, void ratio, and degree of saturation. The final expression will be this one. Just try to keep this in mind because this expression will be useful for deriving the relationship for dry unit weight, saturated unit weight, and submerged unit weight also. The next three relationships. This up to this step, it is very important. From this expression, you can derive the next three relationships. That's why I'm stressing this point. Okay, look at this. So this is the relationship for bulk unit weight. So what happens? The next case will be for dry unit weight. So in dry unit weight, the degree of saturation S value is 0. We already discussed during the degree of saturation definition itself. So for a completely dry soil, the value of S becomes 0, and hence this expression reduces into G into gamma W divided by 1 plus E, like this. And understand this for your sake. Let me write the bulk unit weight expression again here. So gamma B, it is equal to G plus SE into gamma W divided by 1 plus E. So this is the basic relationship between the bulk unit weight and the remaining terminal properties. From this, we are going to alter the value of S. Then we will get the remaining two. So for dry case, the S value will be 0. Substitute that here. Then this expression reduces to here, to this. So gamma D is equal to G into gamma W divided by 1 plus E. Similarly, for saturated unit weight, gamma sat, for deriving the relationship between gamma sat and the remaining terms, what happens? The degree of saturation becomes 1. For fully saturated soil, the value of S is 1. And the expression will reduce like this, G plus 1 into E. Okay, so G plus E. So instead of S, we are going to substitute S as 1. We will get G plus E into gamma W divided by 1 plus E. Okay, clear. Next, submerged unit weight. You know the basic definition: saturated minus unit weight of water. Just put that. So saturated, just now we have calculated here. Saturated minus unit weight of water. So cross multiply these expressions, you will get this one. Okay, gamma sub equal to G minus 1 into gamma W divided by 1 plus E. Right. The final one. Actually, this expression is useful in compaction topics, compaction related problems. This expression is useful. to find the zero air-voids line. There is a line named zero air-voids. Maybe you have remembered that. Maybe you could remember this topic, or you could refresh that in the next sessions. There is a line called a zero air-voids line. When we deal with the compaction related problems, at that area, for drawing that zero air-voids line, this expressions will be useful there. Okay, the relationship between dry unit heat G, W, and Na. So there's a derivation. The final value will be gamma D into 1 minus Na into G gamma W divided by 1 plus Wg. Okay, so you can write this Wg as Se also. There is nothing wrong, because we as I already said, Se is equal to Wg. You can substitute the Se instead of this Wg here. Nothing wrong with that. Okay, right. So this is the final relationship between this phase relationships. Okay, final interrelationship in this topic. Okay, so with this, I'm stopping this, winding up this session. If you have any queries in the properties we discussed so far, you can ask now. I'll try to clarify as much as I can. If you have any queries, please ask.
No queries, sir.
Okay, if you need anything else, means please put it in message or inform to your coordinator, sir. I will try to give you those inputs if you need some materials or question banks like that, or if you want to teach me in some other way, just give the feedback to your sir. I will do that in our next session. Next time we meet, please do it. Okay. Yeah, thank you so much. If you have any queries, please get my mail from your coordinator, sir, and put your mail. I will reply when I find time. Surely we will meet for some other sessions. Okay, sure. Actually, I have prepared. Just a minute. I'll show you the slides. I have prepared the problems also for this class, but we are a bit short of time. So that's why I can't solve the problems here. Just a minute. I have prepared some problems also. I will surely discuss those problems in the next class. Wait, just a minute. I will show those slides. Oops. Actually, I have prepared a few problems for to get a better idea of those topics also. But unfortunately, we don't have much time now. I will surely discuss these problems and again some more topics in our next sessions. Let's meet some other time. Thank you. If you have any queries, please mail, send me a mail, or ask during the next session. I will share this presentation with your sir. He'll give it to you. Okay? You can keep it for reference. Thank you.